Hello, in this short lecture I will give a proof of the Pythagorean theorem. Pythagorean theorem in a right actually says that in a right triangle the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. Actually, if we look at this right triangle, we can say that the hypotenuse squared, that is c squared, is equals to the a squared plus b squared, or the hypotenuse the square of the hypotenuse c squared is equal to the sum of the squares of the perpendiculars, that is a squared plus b squared equals to c squared. Okay, so let's assume that the right angle triangle ABC is this in this triangle we will prove that a squared plus b squared equals to c squared. Now by actually we will build a copy of this right angle triangle. We will build actually along the length of side A. We drew side B, okay, and raised the perpendicular whose length is the length of side A. Okay, so here is 90 degrees, and so we actually built a copy of this right triangle. Now I will prove that the triangle that we built is actually coincidence to this triangle is coincidence to this triangle. Actually now we have two triangles, ABC on the right side and ABC on the left side, whose two sides are equal to each other. Side A equals in the right side equals to side A in the left side, and side B in the right side is equals to side B in the left side triangle. And actually also the angle between these two sides equal to each other. The angle between side A and side B in the right triangle is 90 degrees, and so is the angle between side A and side B in the left triangle. It is 90 degrees because that is how the way we built this triangle. We actually made perpendicular line that is the size of A is perpendicular to B, and for that reason this angle is 90 degrees. So actually we have two triangles that equals in two sides, A equals to A, B equals to B, and the angle between them is also equals. This is 90 degrees and this is also 90 degrees. Therefore, triangle ABC on the right side coincides with triangle ABC on the left side according to the rule side angle side, that is to say two triangles that have two sides that are equal to each other. Here is A equals to A and B equals to B, and also the triangle between these sides is equal to each other. The triangle between A and B is 90 degrees, and also the triangle between A and B in the left side triangle is also 90 degrees. So the triangles are congruent or coincides. Triangle ABC in the right side is coincides with triangle ABC in the left side. And since the third side of the triangle ABC on the right side, the third side is C, then because of the overlap of the two triangles, the third side of the triangle in the left side is also must be C. Okay. Now let's mark the angle between sides A and C with alpha. The angle between side A and C is marked as alpha, and also the angle between side A and C is marked as alpha in the red color. As we know, the sum of the angles in a triangle is equal to 180 degrees. In every triangle, the sum of the angles is 180 degrees. So we don't know which triangle is between side B and side C, so we will mark it as X. So X plus 90 plus alpha is equals to 180 degrees. As you can see here, X plus 90 plus alpha is equals to 180. Alpha is the angle alpha, okay? And if we subtract 90 degrees from both sides of the equation, and then we will subtract alpha from both sides of the equation, we will get that X is equals to 90 minus alpha. Okay? As you can see here, is X equals to 90 minus alpha, and since the sum of the angles on a straight line is 100 degrees, in every straight line the sum of the angles is 180 degrees, and if we mark this angle that we don't know what it is as y, is the variable y, so we will get that the sum of the angles on this straight line is alpha plus y plus x, that equals to 90 minus alpha, is equals to 180. As you can see here, alpha plus y plus x that equals to 90 minus alpha is equals to 180, and actually alpha minus alpha is 0, and if we subtract 90 degrees from both sides of the equation, we will get that y is equals to 90 degrees. So this is right angle equals to 90 degrees. So on now actually we will calculate the area of this trapeze in two ways, and then we will compare the results. Of course, that is the same results, and in this way we will prove the Pythagorean theorem. So from one side, the area of the trapeze is equals to the sum of the sides that are parallel to each other. A is parallel to B, so it is A plus B, and we will multiply it by the height of the trapeze. The height of this trapeze is this line, that is this side, that is A plus B, so it is A plus B times A plus B, that is A plus B squared, divided by 2. So the area of the trapeze is the sum of the parallel sides, that is A plus B, times the height, that is A plus B, so A plus B squared divided by 2. That is first way to calculate the area of this trapeze, So it is, as you can see here, A plus B times A plus B divided by 2, or A plus B divided by 2. So this is one way to calculate the area of this trapeze. On the other end, the area of the trapeze is equals to the sum of the three triangles. These triangles, the area of these triangles plus the area of these triangles plus the area of these triangles is equals to the area of the trapeze. So the area of this triangle is A times B divided by 2. So is the area of this triangle is A times B divided by 2, because it is the base times the height divided by 2, base times the height divided by 2, plus the area of this triangle, that is C times C divided by 2, because it is the base times the height divided by 2. C times C divided by 2, it is C squared divided by 2. So in total, in the second way, the area of the trapeze will be A times B divided by 2 plus A times B divided by 2, that is the area of these triangles, plus the area of this triangle is C times C divided by 2, or it is actually 2 times AB divided by 2, that is actually 2 divided by 2 is 1, plus c squared divided by 2 equals to a times b plus c squared divided by 2. Okay? And by comparing the two expressions, we got to each other, we get the Pythagorean theorem. So we calculated the area of the trapeze in two ways, and of course the area is the same area, so they equal to each other. So we will compare the two calculations to each other, and actually we will get the equation of the Pythagorean equation. So we actually calculated the area of the trapeze as the sum of the two sides that are parallel to each other times the height divided by 2. We got I plus b squared divided by 2 that equals to the area of the trapeze when we calculated it in the second way, that is the sum of the areas of these three triangles, and the area of these three triangles is equals to a times b plus a times b divided by 2 plus a times b divided by 2 equals to a times b, plus the area of the middle triangle, that is c times c divided by 2. So we will compare the area of the trapeze that we calculated in two different ways, and actually of course they are equal to each other, and then we will multiply by 2 this equation. We will get that a plus b squared divided by 2 times 2 is equals to a plus b squared, and a plus b squared is equals to a plus b times a plus b, and c squared divided by 2 times 2 is equals to c squared, and a plus b times multiplied by 2 is equals to 2ab. And then if we open the brackets here, we will get that a times a is equals to a squared, b times b is equals to b squared, and here we will get ba plus ab, that is equals to 2ab, equals to c squared plus 2ab. Then we can deduct 2ab from both sides of the equation. Then we will get that a squared plus b squared equals to c squared, or actually the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. That is actually what we proved here, and actually there is a lot of proofs to this theorem. I showed you only one way. You can find in the internet about 30 ways to prove this theorem, and I hope that you enjoyed from this lecture. Thank you very much.